This video series summarizes the workflow for implementing 3D scanning for the damage assessment of bridges with a focus on the corrosion assessment of steel beams. This training was developed under research project SPR 2310, funded by the Connecticut Department of Transportation. The PIs on the project were Arash Zaghi and Alexandra Hain from the University of Connecticut.
Hi everyone, now that we've gotten familiar with the scanner itself, we're going to focus on how do we use the scanner in the field to do an inspection of a beam with corrosion damage. This has two main parts. The first is the preparation before the scan, and the second is the actual scan itself. Starting with the preparation, the first most important thing is we need to make sure the beam is thoroughly cleaned. The beam that we're using in this trial today has been blast cleaned and then painted, so it's not a concern in this situation. But the scanner itself only captures what is visible. So if you're working on a beam that has heavy corrosion damage, has laminar rust, you need to make sure to thoroughly remove that before using the scanner. The other aspect of this beam, as it was recently painted, is that it doesn't have distinctive features of corrosion, no changes in color and texture along the beam. That's something that normally helps the scanner with tracking. So this is kind of our worst case situation where we have a uniform surface with a slight shine. So that's why today we're really going to focus on where we can put our markers to make sure that we get the best scan possible and that we're able to align it in post-processing. With alignment, there are three main tools that we use. The first is just using markers that we can write on the beam, normally an X mark or an alpha with different colors, just to help with tracking during the scan. And the second two are these alignment bars. These alignment bars have specific spacing between them. We paste one along the bottom flange and one along the web. And what we use those for is if we're not able to get a cohesive scan where all of the geometry is captured in one go, we can get a scan from one side of the beam, a scan of another side of the beam, and we have our scans of the target bars, and then we can put that together in post-processing. The first thing that we want to do is provide some light markings that breaks up the uniform surface. So this just provides another tracking point for the camera. What we typically want to use are X shapes and alphas. The reasons these are good is that they come to one point at the cross. So that's helpful if we have two overlapping scans. We can use that as a point later on to match the two scans. So I'm just going to go ahead and add a couple more to these uniform surfaces. And then you want to repeat this process on the opposite face of the beam. The next thing that we're going to do is place the target bars. I'm going to start with the one that goes on the bottom of the web. This has two magnets that can twist on. And what this does is it goes at the end and it provides something that overhangs from the bottom flange just to make sure we can capture that if we're not able to get a full sweep under the beam. So we're going to have that reference on both sides of the beam. So I'm going to go ahead, turn the magnets on, and then place it underneath on the bottom flange. The important thing here is that we want to be a few feet back from the end of the beam. This is important because sometimes when we're scanning, if we're not able to close the loop, what happens when we're processing is we can have a really accurate scan at the beginning, and then the web can artificially kind of span out if we only have scans from each side. So when we place this farther back as a reference, that has the two tie points to make sure that we're getting that constant web thickness. The second target bar is going to get placed on the web, and that's to provide another tie point at the front of the beam. The important thing about both of these references is that once you start scanning, they cannot be moved. If you bump them, that is going to mess up the alignment later on if you are using those elements. So you want to place that about mid-height and just make sure it's at a place that you're going to be able to capture the scan on. Now that our targets are set up, we can start the scanning process. So what we want to do is turn on the scanner, press to create a new project, and then there are some settings that we have to look into. Once we generate a new project, the first thing that we have to do is check our settings on the main page. The first is the texture brightness, which you can slide up and down with this touchscreen. You can see the beam is changing color, and you want to select a level of brightness that you're comfortable with. You feel like you're able to see the most detail when you move it around. The second is the far plane. What this does is it changes the maximum distance on where the scanner is collecting data. What we're able to do, if we slide that all the way down to the bottom, you see nothing is in view any longer. So typically we want to pick a setting near the top so we capture the most information possible, and then we can filter that out during post-processing. This is something that can be adjusted on a beam-to-beam basis. The last two are the show texture and remove base settings. For our purposes, we do want to show texture. It makes it a lot easier to evaluate the areas that we've collected data in after we've done the scan. And we also want to remove the base. We want to leave that unchecked. Remove base, when that's checked, it automatically finds the base and removes it. That's something that we want to be able to do manually in post-processing. Once that is all set, we can move forward with the scan by either pressing the trigger underneath your index finger or pressing the scan button here. So now we are ready to scan. We can see in our preview that we're able to capture the whole beam. I'm going to go ahead and click that trigger. We don't see the texture in this main area. What we see is green and yellow. And what that shows is the level of information that we're collecting. Green is good, but also our distances. Are we collecting enough information, and are we not getting too close? If we get too close to an area, you can see it turns that red color. So what we want to do is go over all areas of interest, make sure all the holes are filled in, and make sure that everything is green. You want to go from a few different angles to try and capture all the information. In general, the scanner struggles with shiny surfaces and also surfaces that have sharp edges. So just be mindful of the areas like the edges of the flanges and the stiffener. And we also need to make sure we get a good view of those target bars. So all along the top, bottom.
And then we just want to continue scanning all around the beam and getting the target bars. We ideally want to keep the area we're focused on in the center of the field of view of the scanner. In some of those places, like in front of the stiffener, that can be a little bit harder. We also normally like to work with about a 1 foot offset, but once again, that is depending on the geometry. You're going to do the best that you can and just make sure you're capturing all the information. If we're collecting a few too many scans, this is something in post-processing we can go in and delete the scans with higher error. But our main focus is just capturing all of that geometry.
And making sure that we get the large target bar as well.
And then we're moving along to the back side of the stiffener, capturing this information, a little bit of the web. This is also a good spot that we can put some of those markers. And of course, capturing the top of that target bar on this side.
So I'm going to stop scanning for now. And the great thing is after we collect our initial scan, we're able to view what we've collected. And areas where we don't have information are highlighted in red. To zoom in, use 2 fingers. It is a little laggy because this is a big file type. But we're able to view in and see where we're missing information. We can see, looking at the front of the stiffener, this is one of those red areas, so that shows that I'm missing information, so I'll have to go back and rescan that. To do that, I hit the scan button again, point at the beam, and since I'm in the same project, it should be able to find where I am. Once it clicks in, you'll be able to see, and then I will go back and collect that information that I need. We see that area of the stiffener is now showing up. So we want to look at any other areas that may be missing information. And in particular, we want to focus on our areas that have corrosion damage, make sure that we have all the information. So once we've done a check of our first side and we're satisfied with the level of information that we've collected, what we want to try and do is a sweep of the bottom flange to connect the scans from both sides. So what we want to do is start pointing at the scanned area, make sure that it knows where we are, and then start our scanning process again. Come on over to that target bar and then loop down. Capture the bottom of that target bar kind of along the length and as much as the bottom flange as we can. And then the ability to kind of capture all this information on the bottom flange and to have one cohesive scan is dependent on the geometry of the bridge, the level of access, but you just kind of do the best that you can. And I was able to get the pass, get the full target bar, and then what we want to do is loop back up and start collecting our data on this side of the beam. Once again, when you are making that transition, make sure you do not hit your target bars. That is critical. And then we just repeat the process on the opposite face of the beam. So the ease in which you're able to capture the information is very dependent on the geometry of the bridge. So this bridge in particular is challenging due to its skew. It has a skew of about 25 to 35 degrees depending on the beam.